Hello Year 10, welcome to your remote session on electrolysis. Here are your do now questions. Please pause the video and answer these in your exercise book. Now you have answered these questions, I will show you the answers. Please make sure you correct any answers that are wrong and give yourself a mark out of 5. So, this is your title for today's lesson. I'm first of all going to recap the stuff we did in the last lesson of term and then go on to some new stuff towards the end. First of all, we looked at what electrolysis was, and electrolysis is the splitting of a compound using electricity. And we drew and labelled this diagram in our books. We looked at the electrodes, and in electrolysis there are 2 electrodes, one of which is positively charged and one of which is negatively charged. To remember which one's which, we use the acronym PANIC, which means positive anode, negative is cathode. We said that the electrodes are conducting rods and they need to be good conductors so that the circuit is complete and electricity can flow through the solution. We said there had to be a gap between them in the electrolyte to prevent the circuit from short-circuiting and to make sure the electricity actually passes through the electrolyte. We said electrodes are best to be inert so that they do not start reacting and being split themselves. So, electrolysis uses a large amount of energy, and it uses that to split the metal ores. What type of bonding do the compounds found in metal ores have? Metal ores are made up of a metal and a non-metal. Can you remember which type of bonding this is? It's ionic bonding. And under which conditions can ionic compounds conduct electricity? Ionic compounds can only conduct electricity when they are molten, which is when they're melted to become a liquid, or when they are dissolved in an aqueous solution. So, the electrolyte is the substance which is broken apart using electrolysis. At the electrodes, the ions lose their charge and become elements. Positive ions gain electrons to become neutral, while negative ions lose electrons to become neutral. We can look at what is happening in terms of redox by remembering the acronym LEO-GR, where we said that losing electrons equals oxidation and gaining electrons equals reduction. So, if our positive ions have to gain electrons to become neutral, are they being oxidised or reduced? They are being reduced. Whilst negative ions, the anions, are losing electrons, so they are being oxidised. But which ions are attracted to which electrode? So the positively charged anode attracts the negative ions, which we call anions, and the negative cathode attracts positive ions, which we call cations. There are several different uses of electrolysis that we will look at. There is the production of oxygen and helium by electrolysing water. We can use electrolysis to electroplate metals, which is where you coat the metal in a more valuable metal. And it can be also used to extract metals such as aluminium from their ores. So here is a bit about electroplating. It's where a conductor is coated with a layer of another metal. And there are some examples at the bottom. We also use it in the manufacture of chlorine. We electrolyse solutions of sodium chloride to produce both chlorine and hydrogen gas. We can do this on large scale or we can actually do it on very small scale in the lab. So, electrolysis is a method for extracting metals. It is useful for extracting the metals that are more reactive than carbon. Go back to our lesson on the reactivity series to see which metals that is. A current can be passed through the molten ore, which causes the positive metal ion to separate from the negative ions. Can you think of some advantages and disadvantages of this process? So, some advantages are that we can extract metals that we would otherwise not be able to extract. Some disadvantages is that the process requires a large amount of energy, both to melt the ionic compound and to pass through the ionic compound in the form of electricity, and it can produce some dangerous gases such as chlorine. Please copy this table out into your exercise books. Your task is to look at the compound on the left and work out which ions are going to be present when it's either in aqueous solution or electrolysed. So, for example, you will need to look on your periodic table, which can be found in your planner, and you need to have a look at which one is in which. So, zinc chloride. So we're going to have Zn, and we're going to have Cl. Now, chloride or chlorine is in group 7, so it needs to gain 1 electron to have a full outer shell, so its charge will be negative. This means that the charge of the zinc will be positive. You then need to decide which of these two ions is going to go to the cathode. So if we think back to panic, positive anode, negative is cathode. So our cathode is negative and our anode is positive. Now if our electrode is negative, it's going to attract the positive cations. So our zinc will be attracted here. And if we have a positive electrode, it's going to attract the negatively charged anions. So our chloride will be attracted here. Have a go at filling in the rest of the table. Here is an animation showing you what actually happens when we electrolyse zinc chloride. So, the positively charged zinc ions are attracted to the negatively charged electrode, whilst the negatively charged chloride ions are attracted to the positive electrode. And as you can see, that was our first column. So pause the video and carry on with the rest of the table. Once you have finished this, have a go at creating a glossary in your books. I would like each of these words defined in your books, please. Okay, once you have completed this, can you upload it to the assignment on Teams, please? And I will see you next lesson.